Hi there. In this video we will be taking a look at something quite cool that PeakTech sent in. It's a current clamp meter through RMS, and it's a quite high precision one, hence the small gauge here. So let's take a better look. The exact model number 4350. It can go up to 80 amps AC or DC, 4000 counts. And let's get into the box. Comes in its cool little pouch. About the packaging, I don't even need to say it. It sticks with the standard nice packaging of PeakTech. Their brand blue and yellow colors, so it's as good as always. Branding on the little pouch, and in here we have the temperature probe adapter. Let's put that aside. We have the test leads, and from what I feel from this little bag, they seem to be quite good quality. They are decently heavy. So let's get them out and see what kind of material they are. Yes, they are soft and quite thick insulation on them. So that's as expected. Tip like I want it to be poking out just a tiny bit and not make easily shorts. And if you want more, you can always, or can you not? Oh, wait a second. I was wondering why they felt they were a bit thick in here, but I thought maybe just more insulation plastic. Nope. These are banana plugs. Let me just check something quickly. Let's see, just a test. This is off. Yep. Okay. This is actually cool. This is actually quite cool. Okay, wasn't expecting that, honestly. Nice. Back to the meter itself. Let's put this back on. If you want, their specs. Cat 3 1000 volts, Cat 4 600 volts. Let's see this little guy. Batteries, GP batteries, good, known brand, decently heavy. Get them out of the little wrap in here. Do not touch the ends of batteries. In low voltage and low current applications, creating any residue on the ends with dirt or grease from our fingernails can lead to just a tiny bit of corrosion and bad contact over time, so don't touch those. Clamp itself does not open more than this, because basically this is the full thickness of the wire that you can take in, so yeah, more than welcome to get in here without any issues. Let's get rid of the little peel from the screen. How can I show you best? Yay. Okay, let's see the back of it. We need a screwdriver quickly. If you want to read the info. Yep, get this away from any power source before changing the battery. It's quite obvious, and as you can see, and I think in most if not all PeakTech tools, we have an insert, a metal insert in the plastic, so we are not directly screwing into the plastic itself. We are screwing into a metal insert. This will make the tool last longer when you change the batteries, and not have this back cover fall and maybe lose the screw, who knows what. Nice attention to detail with that insert. Oh, and we have light. My bad. Let's see on anything. Does this have any sort of sensor? No, I think it's from here. Actually, no. This is only for this one. Okay. Let's turn off the light. I'll give you a hint on what's happening. So you will get light in your working area from this. Cool. That's a nice little touch. I do not know if we have backlight illuminated. I will check the manual, but we might not have. Oh, but actually we should have it. Hold. Yeah, we have it. Nice and fully readable. I saw the little bulb in here, so perfect. Okay, great. Turn back on the light. Now let's plug in the leads for us. Be back in a second. Actually, nah, I think we can do it live. Yep, I dropped the cover for the leads. That's what happens when you do things live. Okay, nice satisfying insert there. So we have voltage, AC and DC, frequency, oopsie daisy, resistance diode, and continuity test. Let's see the continuity test really quickly. We already heard the unit beeping, so obviously it will beep. Oh, we are in the wrong mode. We are in auto. Now we want to be in, I think this is it. So it's checking also. Yep. Not extremely fast to respond. Yeah, that's the only small downside, not extremely fast to respond for continuity. So if you have something intermittent that's really quick, it might not pick it up. Although if you look at the screen, try to look at the screen somehow. Let's see, how can you see the screen? That's even worse. Okay, you can. That's really bad. I don't have any other way of propping this up. Okay, now you can see the screen. You can see the value. So the unit is registering a modification. So if you have the possibility to look at the screen, you will see anything intermittent. You will just not hear it quickly enough always. So yeah, that's a non-issue at the end of the day, because you can simply look at the screen, and if you see any changing values, it's clear you have something intermittent in there. This is for capacitors, which is kind of cool. Let me just whip out a few capacitors and resistors and be back in a second. Let's measure some capacitors. Took one with a bit longer leads, because these are a bit thick, so short leads could be an issue, could be hard for me to measure. Not really good contact. Let's see now. It is just a tad bit slow at measuring caps from what I see. So 220 microfarads. 220. Where are you? Spot on. Next. What is this? This should be a 100. Okay, ish. Again, longer leads. They are quite dirty, so hopefully we will make a good enough contact in here, but we'll see in a moment. (87.5 micro). So this is below its rated value. Let's see. I'm poking into the capacitor box in here. Okay, got a 1000. Oh, and these are really short leads. Now we'll see how easy it is to measure something with short leads. Okay, easier than I expected it, honestly, I think. Let's wait for the value. Okay, I might actually not be touching it. So it's not as easy as I expected. You can see really short leads. With this, I could always take the plastic off, obviously. That's quite clear. And we're measuring. Yep, for 1000 it does take its time. So 1146 or 1.14 microfarads. Millifarads, not micro. Jeez. 1000 micro is 1 millifarad. So this one seems to be a bit over the rated spec. Let's play with some resistors quickly. 47k. Okay. That's bang on. Okay. What happened? I think I moved it by mistake. So that's bang on 47k. And it's quite quick to measure resistors. So with capacitors, because it needs to charge them, it's a bit slower. But in resistance, it's extremely quick. 150, kind of almost bang on. And yep, 150R. So there's that, exactly as expected. Let's insert the temperature probe quickly. Okay. Adapter goes in. Whip out the probe itself. I'm not going to undo the cable. I don't think it's required. Let's see. Does this care? Yes, it seems to have a plus here. So let's keep the plus at plus. And move to temperature. Okay. We are in here. 29 degrees, 28. Let's see if I touch it. Going up quite quickly. It is quite hot, so there's that. If I leave it, yeah, going down again fairly quickly because it's cooling down. I don't have anything cold to touch now, but I do have something. Let me show you. I don't have cold, but I do have extra hot. So let's see how heated is this pad for mosquitoes. Ooh, still going up. Still going up. Okay. Is this close to 100 degrees maybe? Yes, this might be close to 100 degrees. Okay, a bit hotter than I have expected, honestly. This will go over 100, won't it? Yeah, it will, and it keeps rising. Okay, I never had a clue. This is hot to the touch, but you can see it's not burning me. But the pad underneath it would burn my skin for sure. So luckily, plastic keeps us safe. Let's see the plastic itself, more or less. So yeah, still going down. So clearly the plastic is hot, but so we saw the plastic, we saw the ceramic, but let's see the pad. The pad is also quite hot. And this is about stabilized now. So about 85 degrees for the pad itself, more than 100 for the ceramic, and way less for the protection plastic. Okay. Nice to know. I had no idea how hot these things were up until now. And now finally, let's go to what this current clamp is actually built to do. I have modified this fan. This is why you see super glue fumes on it. Basically, there's a separate video if you search on my channel. I'm not sure if it will be up yet before this, probably not. Where I bought these things, 24 volts, I need to do some ventilation in my attic. So I bought a solar panel that outputs about 20 volts and 30 watts. So I bought two of these, 8.7 watts. It should be able to handle them, but I've opened them up and it seems that these need to be controlled by a separate circuit board. They don't have the electronics on them. So I ripped one of them apart and inside of it basically put a much smaller fan, one of these, not exactly the same model, but a 24 volt small fan, and modified it, glued it in there to work with the external, the skeleton of the big fan. And let's see how much current it draws now. It should draw a 0.1 amps when it was like this, but now it's like this. I have no clue how much it will draw. So let's basically play around. So I'm starting my PeakTech. Let me try and change the angle of the camera. Hopefully you can see everything. Let me rotate the fan because it will blow air towards us and probably affect the video, the sound of it. So we have the current clamp set to AC, so milliamps, mode DC. Let's go to DC now because this is DC, and max 1 amp. I'm giving it just 12 volts to start with. Let's see. And it's slowly spinning. 34 milliamps more or less. This says 46 milliamps. Close enough. I'm not sure if we have any losses in the system, which one of them would actually register them. So there's that. Let's increase the voltage. And we are getting closer to that 100. And this fan is starting to take off. Let me just check something with my hand at least. Wait a second. Why is this rotating in reverse? Oh no. Oh no 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 no. Were just these two fans actually in different directions? Oh no, please no. That would basically suck. This is rotating backwards. Whew. Okay, be back in a second. My plans got destroyed. So these fans, not only they were useless because they needed external control and drive, not only control, but they are also backwards from most computer fans that I've seen. Or these are backwards. Let me check. Nope, most computer fans rotate like this. Like this one, and not like this one. I don't think it works just to give it reverse voltage. They have electronics controlling the rotation. Yeah, so about that fan, my disappointment is immeasurable and my day is ruined. Yeah, win some, lose some. I will need to see what I can do about it in its own video, obviously. So let's bring it back on, raise the voltage to 24 volts, and this is saying 100 milliamps, and this is saying about milliamps, 80 milliamps. I might have just realized something. Let's shut this off. This is showing a value from the start. Let's wait for it to settle down. And we can use this to zero it out. I'm not sure. I've seen just another clamp only one other clamp I put my hands on, and it was also in DC mode showing a value. It wasn't zeroing out. Not sure why that's happening with them. And now let's measure. And it's bang on. So yeah, if you measure the delta, you see the real value. You kind of need to zero it out in DC mode. Not sure why that is, but as you can see, they are showing almost identical things, more or less. So yep, now let's go play with some mains voltage. Just want to mention something. Do not think that you can simply go on I don't know, amps, AC, and measure something like this. Hey, it's zero. Nope, because it doesn't work like that. It needs to measure, to put the clamp over either phase or either neutral, not both of them at the same time, because it cannot measure like that. It's not how this works, basically. So let's go to the electrical panel, where basically I how many times did I say basically? I have a 30 milliamp differential fuse for the whole house. I have others for the bathrooms, 10 milliamp ones, but for the whole house there's a 30 milliamp, and kind of the general consensus is that it's a bit too small, and actually not too small, too sensitive, because it's good to have a low value one, but it's that sensitive that it should trigger all the time. Well, mine kind of isn't triggering. So, and it is working when I use testers on it, so it's doing its job, but it's not randomly triggering by itself without any reason, which is great for me, but I wonder what's the residual current that it doesn't get triggered by mistake. So, which is awesome again, but let's see the residual current. And we are on the ground wire, and this is the residual current. So this is why it is not triggering, because we are way below the 30 milliamps, which is perfect. And it's kind of in line with what this seems to say, but I had no faith in this TOMS, whatever it is. But in this, yep. And as you can see, it's going up and down depending on whatever the devices inside the house are actually doing. And now we are measuring the amps drawn by the whole house on the live wire, and it's again in line with what this says, which is great. So that's about it. This seems to be reading exactly as that weird no-name meter that I installed there, because I was almost above the 300 kilowatts that we are allowed to use in Romania at a decent price. Then the price doubles, so I needed a kilowatt meter or whatever it's called, and seemed to have also a display for residual current, and it actually seems to be accurate. This proved that that's accurate, and that proved that this is accurate. Rarely two tools fail in the same direction and give the same reading, the wrong one. So it probably is the right one in this case. And overall, this will be used on the channel for electronics, because as you could see with that fan, you can check whatever something is drawing at a point in time, and if it seems too low or too high, it kind of starts to raise a few question marks and gives you a hint of what could be wrong. But as an average user, I think that a tool like this can be used for the whole house, honestly. If you go above the 80 amps that it can measure by clamping onto the wire, you are either doing something wrong, or you are a power user with really heavy tools, and then yes, you might need an upgrade. But for the average user, this is an all-around great tool, and yeah, I do recommend it. A really quick look over the documentation. We have the calibration sheet. Everything passed. That's what we want. And just a really quick look through the manual. In PeakTech tools, if you want English, go from the middle. Up until there's German. I will go really quickly through it. This is a long video. I played around with the tool quite a lot. Yes, above 25 AC or 60 DC considered dangerous, so be careful. That's what I can always say. Be careful what you are doing. If you are not experienced, just don't. It's easier, honestly. All the specs, the accuracy, the resolution. Resolution does not equal accuracy. Resolution is basically what it can show you on the display, and accuracy is how clear and accurate the measurement is actually. So accuracy is important. The layout, if you want to read it. How to make the measurements. Yes, obviously the manual is on PeakTech website. You can find it in the link below, but I always show it because if you are watching this video, maybe it already helps you directly. Feel free to pause. And that's about it. And I just want to check the range for capacitors, just out of curiosity. So yes, 500 microfarad is basically kind of the peak. I think we were above it just a tiny bit, or weren't we? I think we were actually, yeah. So there's that. So if you have any questions, feel free to ask in the comments. Thanks again, PeakTech, for sending this in. Will be put to good use. And as always, see you all in the next video. Bye.